All right. Hello, everybody. I'm going to work through a couple worked examples on this progress packet that I think might be helpful from each section. So we're going to go through number 2 here. Okay. So with these types of problems, you want to identify your A and your B. Now, since it's an ellipse, we know that, well, whichever term is larger is going to be our A term. And clearly, well, I guess the first problem is it's not in standard form. Before we do any of that, we need to get it to standard form. And this dividing by 4 is really what's messing us up here. So what we have to do is first get rid of that divide by 4, multiply everything by 4. You don't want to divide everything by 25 right away because then you're going to have, well, a numerator. Something in the numerator, which you don't want. So we're going to multiply by 4, which will effectively reduce this. We're going to be left with 4, not 4x squared, we're going to be left with x squared plus 4y squared equals 100. Then you want to get it into standard form. Divide everything by 100. So you're going to have x squared over 100 plus, well, 4y squared divided by 100 is going to give you just y squared over 25. And that's going to equal 100 divided by 100, which is 1. So you can tell, well, your A is going to be equal to 10, since A squared is this value. B squared is 25. I guess A squared equals 100, so A equals 10. B is going to be the square root of 25, which is 5. And you can use these to plot your vertices here. So, since the larger value's under the the x term, you know that this is going to be horizontally orientated. So your vertices are going to have x values, and that x value is going to be determined by a. So it's going to be plus and minus 10, 0. Our covertices, again, since it's horizontally orientated, we know that the covertices are going to be on the vertical or on the y-axis, and that's going to be, well, 0, and then plus or minus your b value, which is 5. Okay, now to find the foci, we need to do that relationship. We know c squared for an ellipse equals a squared minus b squared. So plug in your values, and you'll find that c squared equals 100 minus 25. So c is going to be the square root of 75, which is about 8.66. So our foci is going to be, well, again, it lies on the same x-axis that the vertices do when it's orientated this way. So it's going to be plus or minus 8.66 and 0. So that's how you do number 2. Okay, number 7, we want to, okay, and I messed this one up. This one should say focus. We want to write an equation of an ellipse with the given characteristics and a center at 0, 0. So our end goal is to get something that's like x squared over something plus y squared over something equals 1. So first we need to identify what's going on here. Our vertex and our focus, we know that those lie on the same region. And if you ever want to sketch a graph, you certainly can. This is going to be my a value. This is going to be my c value. And then you just use that relationship. We know c squared for an ellipse equals a squared minus b squared. Plug in your values. You know that c squared is going to be negative 4 root 3 squared equals a squared 13 squared minus b squared. Okay, well, you squared this negative 4 root 3, you should get 48 equals 13 squared is 169 minus b squared. Subtract 169 from 48 and you'll get negative 121. Then divide by that negative 1. You should get 121 equals b squared. You could find your b, but we really don't need to, since our goal is to just write an equation. Our goal is to just write an equation here of an ellipse. Well, we know it's going to be x squared over something plus y squared over something equals 1. Well, we found our a squared value. Our a squared value, well, a is 13, since that's our vertex, we know it's going to go under, and it's on the x-axis, we know it's going to go under that x value, so it would be 13 squared, which is 169. Y squared is that b value is going to go under here, and our b value we found to be, well, the square root of 121, so b squared is just 121. And that's how you would do number 7. Okay, number 10, we're moving on to hyperbolas here. This one was a little weird. I'm going to leave the graph up there so I don't have to resketch it, but I'm going to erase this stuff. Okay, now when you're working with hyperbolas, your a value is always going to be under the positive term. And since y squared is the positive term, we know a squared equals 81. We know b squared, you don't really see anything in the denominator, which implies that it's 1, so b squared equals 1. So we know a is going to be 9, b is going to be still 1, if we needed that information. All right. Now, we want to identify our foci, so we can't just stop with this information and call it good. We need to find our foci. And for an ellipse, we know that they're related. C squared equals a squared plus b squared. So just plug in those values. We know c squared is going to equal, well, 81 plus 1, which means c is going to equal the square root of 82, which is about the square root of 82. It's a little bit more than 9. What is it? Okay, 9.053. All right, now, this is where you have to think a little bit. We know that since our a term is under the y squared, we know we are going to have a vertical axis here. We're going to have a vertical axis, which means that our point, our vertice, is, since it's lying on the vertical axis, we haven't shifted our center anywhere, it's going to be 0 and then plus or minus that a value. So plus or minus a is 9. Okay, our covertices, we didn't really call them covertices in the notes, but we'll call them that here. Basically just these side pieces that are on the rectangle. It's easier to just call them covertices to give them a name. Those are going to lie on the x-axis, so that means that we're going to have plus or minus 1 and 0. Okay, now I'm going to move this down a little bit so I have a little bit more room. There we go. Now we know, goodness, what is going on? Okay, we know our c value, which means our foci is going to lie on the same line that our vertices lie on, and since they lie on the vertical axis, our foci is going to do the same, which means our x value is 0 on that y-axis, and we're going to have, well, we found it to be about plus or minus square root of 82, or 9.05 if you want to write that. Okay, and then this is what our graph would look like. So plot your vertices, plot your covertices, that's these rectangles, right, or this square here that I'm making, or this circle I'm making a little bit larger. Make your square, and then kind of make your asymptotes. Does it ask for the asymptotes? Kind of surprised it doesn't. No, it doesn't. And then just kind of roughly draw your hyperbolas here, I guess your two parabolas to make the hyperbola. Okay, number 14. We want to write an equation of the hyperbola with the given characteristics and center at 0, 0 again. So we are given the foci. We're given the foci, 0, negative 4 root 5, 0, 4 root 5, and the vertice, 0, negative 4, 0, 4. We know that this corresponds with our a value, and we know that the foci corresponds with our c value. So we know, well, what we want to do is write an equation of the hyperbola. Our end goal is to get something like y squared minus 0, which is just this. You either want y squared over something, or you want x squared over something, over a squared minus y squared over b squared. We want one of these equations. Now, I guess, can I undo that? Yeah. We want one of these equations. Which ones do we want? Well, we know that our a value, since we have an a value, and if you want to draw a sketch, our a value is our foci and our vertice lie on the same region. It's going to be somewhere down here, somewhere up here, something like this. Okay, since it has a vertical major axis, you know that the equation you're looking for is going to be y squared minus x squared, where a goes under that y. Since y is our positive value, we know it's going to have a vertical major axis. So what we do is, well, we know our a, we know our c, let's find our b. And the equation that relates those quantities is c squared equals, when you're working with a hyperbola, it's a squared plus b squared. Okay? So we're going to have 4 root 5 squared equals a squared, which is 4. Okay, 4 root 5 squared gives us 80. 4 squared is 16, which means b squared is going to be 80 minus 16, which is 64. And we don't need to find our b value because we're not graphing anything, we're just writing an equation, so just plug these values in. We're going to have y squared over a squared, and a squared is going to be 16 minus x squared over that b value, or b squared, which is going to be 64, and that's going to equal 1. So that's how you do that problem there. Okay, I'm going to erase this. This isn't really necessary. Okay, so let's move on to number 17. This section, I imagine, was a little bit trickier. Really, your challenge here is to kind of find the center and then just keep in mind that these things represent distances. These things represent distances. These A's, these B's, and these C's. Okay, so start by finding your center. And we know our center, well, I guess maybe start by identifying what kind of conic it's going to be. We have, you can imagine x plus something squared equals -8 times something. So this should look familiar. It should look like something like x squared equals 4py, that kind of deal. So we know that this should be a parabola. We know it's a parabola. Let's find that quote-unquote center point of the parabola, which is really just our vertice of this parabola. Let's find that h, let's find that k value. Remember, the h goes with the x, the k goes with the y. So our h is going to be, normally if it was x minus 4, it would just be 4, but remember, if it's positive, it's kind of the opposite of that. So it's going to be -4 for our h value. Our k value is going to be 2. So that we have just identified, that's going to be our vertice. The vertice is going to be -4 and 2. So we can plot that. 1, 2, 3, 4, 1, 2. Now, we know that since it's x squared equals negative something, that this parabola should open down. Since it's x squared equals negative something times that y, it should open down, which can kind of help us find our focus here. And really, remember when we're with these problems, we're trying to find our p value. And remember, it's 4p times y minus k. Well, we need to find our p value. We know 4p equals -8. 4p equals -8, which implies that, well, if you divide by 4, p is going to equal -2. And remember that this kind of should be, you use your p value to find your focus, and it's kind of difficult to think about that when we're shifted away from the origin, because usually your p value, if it was -2, well, that would tell you that the focus is just going to be, if it was at the origin, it would be 0, -2, then the directrix is the opposite of that. Okay, but really just keep in mind this is a distance, kind of a distance value. So we have a distance of 2 for our focus. So it's going to be, well, since it's -2, or since we know that it opens down, I guess that might even be a better tip. Since it opens down, we know our focus is going to be 2 away from that vertex. So 1, 2, like this. And we know that our directrix is going to be 2 above that value. So that should be, well, 1, 2, go through here. And remember, our directrix is a line. Okay, so let's just finish graphing this. And let's identify what we need. We already have our vertice. We need our vertice. What else does it say? Identify directrix and focus. So our directrix, remember that's a linear equation. That's going to be y equals, and then we get 1 up 2, which is a value of, well, 1, 2, 3, 4. So y equals 4. Our focus, that's just a singular point, and we went down 2 from the vertice. So that's going to have an x value of 1, 2, -3. Whoops. 1, 2, 3. Should be -4 and 0. So I graphed this on -3, but it needs to be moved. So let's do that. Just move it over 1 spot. There we go. And now am I at -4? 1, 2, 3, 4. All right, now we're good. So I graphed that incorrectly at first, but now we're all right. So that's how you kind of do those ones. You want to identify what kind of shape it's going to be, and then find the necessary information. Usually start by finding your center point or your vertex on those ones. All right, the last, or I guess not last one, a couple more. 23. An ellipse with vertices at -3, 4, 5, 4, and a foci at negative 1, 4, and 3, 4. So what you have to do here is, since we know our vertices, and on these ones I recommend maybe drawing a graph, at least a rough sketch so you can kind of see what's going on. We know our vertices are going to be, and I'm actually going to just 1, 2, 3, 4, 5. You kind of want to find the center point. Our vertices, notice that they and our foci all lie on this region, so it's going to be they all lie on a horizontal line since all those y values are the same. So we know it's going to be horizontally oriented, which means we know it's going to be x squared minus, well, x minus some k value squared over a squared. It's an ellipse, so plus y minus k. This should be h k squared over b squared equals 1. That's our end goal here. We have to find our a, we have to find our h. Well, we plot these points if you want, and we know that it's going to have, well, negative 3, 4 be about here. And then we have 5, 4, 1, 2, 3, 4, 5, 4. These are our endpoints. Our focus is at negative 1, 4, and 3, 4, 1, 2, 3, 4. We want to find that center so we can determine what is the distance. Remember that a value represents the distance from the center. What is the distance of these things from the center? Then we can find our a value and our c value. So to find the center, just find the midpoint of either the foci or the midpoint of the ellipses. So the midpoint is going to be, well, the average of the x values. So 3 minus 1 is 2 over 2. 4 plus 4 is 8 over 2. So our midpoint is going to be 1 and 4. So we can plot that midpoint, 1, 4. But really we're using that midpoint. Our midpoint equals 1 and 4. And we're using that to find our distances. So our a value is going to be our distance of our vertice from the center. And if you go either way, well, negative 3 is a distance of 4 from 1, or you could say 5 is a distance of 4 from 1. So that implies a is going to equal 4, since it has a distance of 4. And since our foci has a distance of, well, let's find that out. The distance from 1 foci to 3 would be 2, so that's a distance of 2. That implies c equals 2. So plug these into our equation for an ellipse. We know c squared is going to equal a squared plus, for an ellipse it's minus b squared. Minus b squared, plug in your values. So c squared, well, that's 2 squared, that's 4, equals 4 squared is 16 minus b squared. Subtract 16 from 4, you get negative 12. Divide by negative, you get 12 equals b squared. So just go back up, plug these into our equation here, and you should find, well, x minus our h value. And our h value is just that x value of our center, which we found to be 1. So it's going to be x minus 1 squared over our a value squared. Well, 4 squared is 16, plus y minus our k value, and our k value is 4. So y minus 4 squared over b squared. Well, b squared is 12. And that's going to equal 1. And that's how we get that equation there. Okay. So on these ones, it kind of helps if you draw a sketch. Identify your center. Use that center to find your distances, your a, your b's, or your c's, in whatever case that might be. Okay, so we'll move on to our last example here. 27 and 28 I anticipate might be one of the trickier ones for you guys, so I'm going to work through 28 here. And here's what you want to do on 28. Okay, we have this long thing. You can see that if this is going to be in the general second equation form, or second degree equation, whatever that's called, I can't remember. Which means that you're going to have some ax squared plus bxy plus cy squared plus dy plus, I guess it'd be dx, plus dx plus ey plus f equals 0. Lots of things going on here. But really, we want to use our discriminant here. We want to use our discriminant And then we want to determine what type of conic it is, and then write the equation of that conic. So really, for our discriminant, remember in the quadratic equation x equals negative b plus or minus the square root of b squared minus 4ac. That's what we want. B squared. That's our discriminant, b squared minus 4ac. So we need to identify what our b is, what our a is, what our c is. Okay, a is going to equal whatever term is in front of the quadratic, which is 1. B is going to equal what's in front of that x times y. Well, do you see an x times y? No, so b is 0. And c is going to equal what's ever in front of that y squared, which is negative 4. So plug that into your discriminant, and then its value is going to kind of help you determine what type of conic section this is going to be. So we know, well, if we plug this in, b squared minus 4ac, that's going to be 0 squared minus 4 times a is 1 times a c value of negative 4. We are going to get negative 4, well this is 0, negative 4 times 1 times negative 4 gives us positive 16, which is greater than 0, which is only one option. We don't need to look at our a's, we don't need to look at our b's. We know since our discriminant is greater than 0, this implies we have a hyperbola. Okay, now we could have this hyperbola shifted, so let's just write the kind of standard form of a hyperbola, but keep in mind that it's going to shift with that center h and k. We want something that's going to look like x squared over a squared minus, and then I guess I should rewrite this so we can include that center, x minus h squared over a squared minus y minus k squared over b squared equals 1. Or we kind of want the opposite of that. We want y minus k squared over a squared minus x minus h squared over b squared equals 1. And we have to figure out which one is which. Okay, but we have this giant mess of an equation up here. And what we have to do is first get the constant terms to the other side, and then we want to group the y's with the y's and the x's with the x's, and then we kind of want to complete the square after that. We want to get all the constant terms to one side, and the only constant term we have is 24. We want to group our x's together and our y's together. So we can rewrite this whole thing as x squared. Let's do pink. That seems fun. I can rewrite this as x squared and then group my other x, so plus 8x, and then minus 4y squared minus 24y, and I'm going to move that negative 24 to the other side so it becomes a positive 24. And what we do to complete the square, look at each of these things individually. Let's do plus this. And if you can factor anything out, factor it out. X squared plus 8x. Except for you don't want to factor out the variable term. So if you can factor out any coefficients, you should do that. But there's no coefficients they have in common. I'm just going to leave this as x squared plus 8x. Okay, minus. The reason I'm doing minus is because you can factor out a negative 4 from here. So that's going to be negative 4 times y squared minus 6y equals 24. Okay, now to complete the square, remember what you do is typically it's something like x squared plus bx. And what you do is you do b over 2 and you square that value, and then you both add and subtract that value inside there. So you take this term, this 8 and this negative 6, divide it by 2, and then square it. So 8 divided by 2 is 4, 4 squared is 16. So we're going to add and subtract that in here. We go x squared plus 8x. And then, well, divide that by 2, that's 4. 4 squared is plus 16 minus 16. Okay, that's all in this parenthesis. Minus 4 times y squared minus 6y. And then divide this by 2, which is negative 3. Negative 3 squared is 9, so both add and subtract that 9. Now the reason, and then we still have 24 over here, the reason that you see this step skipped a lot is because essentially this is the same as if you have this negative 16 on this side, it's the same as adding that 16 to this side. And if you have this negative 9, and you want to be careful, technically it's negative 4 times negative 9, that's the same thing as doing negative 4 times negative 9 and then moving it to the other side. So really what we're going to do here, I'm going to write these in black, or I guess just maybe a different color. Let's do green. what you want to do here is move these values that I have in green to the other side, since they're technically constants. These are, oh, whoops, that should be 9. These are constants too, but you want to leave the positive terms because that makes them perfect square trinomials that are then factorable. Okay, so we're going to move this negative 16 to the other side by adding it. We're going to move this negative 9 times negative 4. Technically, we have to bring that negative 4 along for the ride. So negative 4 times negative 9, that gives you 36. So really, we're subtracting 36. So we're going to have x squared plus 8x plus 16 minus 4 times y squared minus 6y plus 9 equals, and then if you do 24 plus 16, well, 24 plus 6 gives you 30 plus 10 is 40, minus 36 is just 4. So we're getting close here. Now we have created factorable things. That's the whole point of completing the squares, to create factorable things, which we need to do to get it in this or this form. And you should recognize, well, which form is it going to be in? And I guess that'll kind of write itself in the end, but you should recognize this y value is going to be the negative one. So really it's going to be this first one. Okay? Now, we're going to go ahead and complete the square by factoring these perfect square trinomials. X squared plus 8x plus 16, that's just x plus 4 squared, minus 4 times y squared minus 6y plus 9, that's just y minus 3 squared, equals 4. And we're in the home stretch. We want this value, this constant, to be 1, so what do we have to do? And we have to divide everything by 4. Divide by 4, divide this by 4, divide this by 4, which is how we end up, in the end, with this answer. We're going to have x plus 4 squared over 4 minus, well, 4 divided by 4, 4y minus 3 squared divided by 4 is just going to leave us with y minus 3 squared equals 1. So that one works out nicely for us. That's how we do that. So basically, this one's pretty involved. You have to use the discriminant to classify what it is. Make sure you get that right, because you're going to use that to determine what equation you want this to look like, and you're going to have to complete the square in these problems. If you're unfamiliar with completing the square, make sure you brush up on that. Maybe watch a video online. Alright, that's all I have for this. You can always hop on a Zoom meeting if you have more specific questions over different problems, but these are the ones I'm going to upload. Alright, have a good day, everybody, and make sure you stay safe out there.